Emil, I just cleaned up my entire floor. We got trash under you. What's going on? You better school him, Victoria. All right. It's sorry for the jiggly screen. This is the online. So I synced my OneDrive, Microsoft OneDrive to this, so it can. Don't. I'll tell you what I'll do. I'll tell you what I'll do, guys. For 4-2, I'll go ahead and copy this over. It won't wiggle once it's on the other screen. There we go. Okay. I don't know. I'll say for now, I'll say that I don't know why the document was wiggling online, and now when somebody watches this on my YouTube channel, I'll get the same person going, actually it's wiggling because of this reason. I can't believe that you're even qualified to be a math teacher when you don't even know why the screen's wiggling. Oh my gosh. Yeah. So, I don't know. Okay. All right. Let's drop the volume. Nature of quadratics. Nature of quadratics, guys. Sure, go ahead, Lucas. You're failing, Lucas. All right, so we're looking at a few squared binomials to detect the pattern. Take that hat off, Wyatt, and take that earbud out. So, who's got the pattern for me? Raise their hand. Go ahead, Sada. So, if we expand x plus 3 squared, we end up getting x squared plus 6x plus 9. If we expand x minus 4, the quantity squared, we get x squared minus 8x plus 16. If we expand x minus 5, the quantity squared, we get x squared minus 10x plus 25. What is the pattern? Yes? Yeah. Yeah. So the pattern, Destiny, Sada, the pattern, this number here is always double this. And this number here is that squared. Double that, you get negative 8x. Square that, you get positive 16. Now, it's not quite as easy as that. This is because of the fact that we have a 1 in front of our x squared. It's because we have a 1 in front of our x squared. If there was not a 1 in front of our x squared, things would be a little bit different. But for now, we're taking a look at this easy case, and you guys might be able to develop your own case later. So, let's go ahead and use this pattern to fill in the rest. Back to wiggly screen. Hey! It stopped. Maybe. For now. There's something happening here. What it is ain't exactly clear. There's a man with a gun over there telling me I've got to beware. Oh, yeah. Okay. Maybe. You guys have to listen. Did you guys hear when you guys watched the video? Did anybody? It did. How much did it catch the students?
Oh, it did catch them a lot. It did catch them when she shot it, though.
Yes.
There you go.
Are you Sarah?
All you hear
I'm going to get the police here. All right. So let's use that. Let's jump back to Anthony. Anthony, can you use that pattern to tell me what this would be? X plus 6, the quantity squared. Use that pattern that Nathan told us. X squared plus 12x plus 36. Okay. So, Manuel, what would be the next one then? Uh-huh. Negative 12x, positive 36. Good. Because when you square the negative, it still turns positive. That's why that last term is always ending up being positive. So, Destiny, do you know what the third one would be? Bless you. Yeah. X squared plus 16x plus 64. They're actually just making up random numbers, and I'm just writing them down and acting like they're completely right. No. It's double the number, then square the numbers, Sada. Double the number, then square the number. Double 6, square 6. Double negative 6, square negative 6. Double 8, square 8. So Sarah, what would be the next one? X squared minus 22 plus... I feel like you could voice the minions from Despicable Me. 121. Okay. All right, we've got our little paragraph saying exactly what Watkins said. From these, we can see that the middle term of our trinomial solution is double the second term of our problem, and the last term of our trinomial solution is the second term of the problem squared. In other words, and here we are without actual numbers, x plus b, the quantity squared, is equal to x squared plus 2bx plus b squared. Once again, I'm keeping the coefficient of our squared variable 1. And when we complete the square, one of our steps is going to be get the coefficient 1. So it's okay that we're using this limited pattern. We okay so far? Sarah, were you able to pick up what we were doing?
Yeah.
Cool. Let's see if it goes back to wiggly. Wiggly screen. Wiggly screen. Okay. I'm trying to get you guys sleepy. All right. I'll let Wilson take the last two, and Indigo can take the first two. Okay. Because I like Indigo's first name. I'll use Eve. I love Jada's first name.
So why do you love her first name and only like mine?
What's I'm just wondering how come both of you can be found in a box of crayons.
Indigo and Jade, get it?
Yeah. So. Okay. Indigo. What do we got? 49. And I want you guys to pause and think about it, especially those of you who are talking, like Wyatt and Tyrell. Okay. That's why I'm help each other out really quick. I want you guys to try to figure out where those numbers came from. If you're still struggling, that might help you figure out why they use those, why they got those numbers. Is everybody good? Let's get it. Yeah? Cool. All right, so then Jada. 100 and 144. I'm going to erase those in a second. I want to actually use the squared. Like, I understand you guys know what those numbers are, but I actually going to want to use 10 squared and 12 squared. And that's going to be important when we complete the square to just give us a little extra step. It kind of eliminates the step that we'll have to do. Lucas, I don't trust you. I don't know. You're going to say something inappropriate that only my mic can catch, and then I'm going to have to actually watch this video and edit it, and I don't feel like doing that.
do that at home as a hobby. I actually do edit.
Well, by all means, Aaron, you can watch these and always tell me, like, Mr. Bates, you need to cut from 232 to 236.
No, I actually I cut everything.
No, well, fine, if you want to edit it yourself. But
Dude, what are you doing?
okay,
I do Dungeons and Dragons podcast and gameplay.
all right.
I'm lazy though. It's challenge. It's really childish.
All right, guys. Next page. So right now, pencils down, eyes up, because there is nothing to write on the next page. I filled in everything for you. I want you guys, because you need to be able to follow this pattern. It is. That was extra. But, Kylie? So, guys, completing the square. You've done this before in Algebra 2, whether or not you remember, because this was done in Module 4 of Algebra 2. So it was done right around the end of the first quarter, beginning of the second. About this time last year. So it has literally been a calendar year since you may have completed the square in class. So we can solve by completing the square. We are forcing, going back to the previous page, we are going to take something that looks like this, focus very clearly. We're taking something that looks like the right side and turning it into something that looks like the left side. Okay? So when we do this, I don't want, we're going to start with this and end up with that. I don't want to hear out of you, what happened to the 22? We're all okay going that direction. So we need to be okay going that direction. You just had this lesson. So, are we okay? All right. So, we're going to force this to happen because right now, guys, if I said solve for x, it's on two terms. You wouldn't be able to do it. We need to get x in only one spot in order to solve for x, and completing the square is a singular method in order for us to do that. So the first thing we do is we move whatever not attached to an x, our constant term, to the other side. So the negative 16 becomes positive 16 on that side. We good? Okay. So then, just like the previous ones, when Indigo and Jada were doing this, they said what would be added to this. They divided 6 by 2, got 3, and squared it. 9, right? Don't write that. If you guys want to write it later, you can. Okay? 3 squared, 3 squared. She's terrible at listening directions. So, that's where the 9 came from. Half of 6 squared added to both sides. This is now a perfect square. Just like before, I said now we're going the other direction. We're taking this trinomial and we're turning it into a binomial squared. And that binomial squared will be x minus 3 squared. It's always that letter, that sign, and that number. That's what will happen because we forced it to happen that way. And we have the 9 on both sides because what you do to one side, you do to the other. Same thing we've learned since forever. We're keeping the equation balanced. 16 plus 9 is 25. To get rid of the square, I square root both sides. So x minus 3 is equal to positive or negative 5. Add 3. X is 3 plus or minus 5. 3 plus 5 is 8. 3 minus 5 is negative 2. Those are the steps of completing the square. They can get ugly in appearance, but the steps are not changing. If you guys want to write that little note down, go ahead. Like 5 seconds, 10 seconds. Well, once I have the The really annoying part is once I actually have a webcam here, the difference between my voice and my actual movements is going to be, there's going to be delay, and I don't like that.
I still think I should have a what a lot of people do for things like that is they record with that microphone and they'll have a webcam. What they'll do is they'll do a clap and they time it so that way it can match up the clap and then the voice and the video works.
But I'm not actually going to go into my video editing software in the slightest and shift anything, even if it's half a second, because this has already taken more time than I want. Yeah. Oh, I know. I know. Okay, any questions here, guys? Any questions? Completing the square? Shh. Guys, quiet down. Marisa? So complete the square. So once I've got this trinomial that I built purposefully, since I built this trinomial, it is a perfect square. All right? So since it is a perfect square, I can put it back in a box. That's kind of how I look at this process. Taking this is expanded. This is like opening a box, taking everything out that you're going to put together and laying it out, right? And then all of a sudden it's like, oh man, we've got to go. So what do? I take everything, I pick it up, I put it back in the box, and I fold the flaps over, and I end up with this, right? It's much neater, cleaner, it's smaller, right? But it still contains all of this inside of it. But it needs to be a perfect square in order for that to happen. If I want to make it a perfect square, I always take half my middle term, square it, add it to both sides. This is a perfect square. It will fit perfectly in the box. It's always that letter, that sign, that number squared. We're going to take a look at an uglier version. It's ugly. Because it's all filled out for you, Destiny. Yes, you will.
Yeah. We could just copy the steps. Right?
Yep. The steps don't change. There we go. Right? Okay. So you guys are getting ahead. We'll do quadratic formula in a bit. Yep. I know. So solve 3n squared plus 7n plus 7 equals 0 by completing the square. First step, remember I told you guys the coefficient in front of our squared variable needs to be 1. So the first thing I do is I divide everything there by 3. I divided everything by 3. That made my coefficient in front of my n squared 1. Are there any questions on just step 1? I divided everything by 3 to get my coefficient in front of n squared to be 1. 7 doesn't divide by 3 evenly, so we get 7/3 and 7/3. I move now the steps match the last one. I move my constant over. So it's now equals negative 7/3. Are we still good? Okay. Okay. Here's the thing now. I've got to take half of my middle term and then square it. We have to understand that half of 7/3 is 7/6. Okay? And then I'm squaring it. What's 7/6? So I just put 7/6 squared, 7/6 squared. Then I actually squared it. 7/6 squared is 49/36. Any questions? That's to complete the square. You take half that middle term and square it, and that's what you add to both sides. Half the middle term squared added to both sides. And then we come back to Marisa's question, right? So I've forced this to be a perfect square. As ugly as this is, it is a perfect square. And once again, it's that letter, that sign, that number squared. That letter, that sign, that number squared. Then here I combine like terms. Negative 7/3 plus 49/36 is negative 35/36. So what did I have to do on this? find the common denominator. Correct, Aiden? I had to find the common denominator on this. So just understand that on this one, I multiplied. So maybe I'll do this. So we get negative 84/36 plus 49/36. All right. That's what happened right there. If you guys didn't know, we just got a common denominator in order to add those fractions, and we got that. Sauter, you got to tell me where I lost you then. The arrows. So once I always take half the middle term and square it and add it to both sides. Okay? Half of 7/3 is 7/6. Okay? So, right, half of something is multiplying by 1/2? Okay. So, now since I've completed the square, that's literally what this process is called, I can take that letter, that sign, whether it's positive or negative, that number, and then I put it in parentheses squared. I'm putting it back in the box. Okay? Then I just combined those two numbers, which is this math right here, to get this side. I'm trying to get n by itself, so now I square root both sides. I decided to put the negative in the top in the numerator. I could have chosen whichever. Just always choose it to be in the numerator. It's easier. Well, at least it makes the problem flow. So the square root of negative 35, there is no square root of 35, so it stays under the square root. But the square root of a negative is I, so the I comes out. Square root of 36 is 6. Then I subtract the 7/6 over, and I split it into my two answers. These are the steps always for completing the square. Yes, Indigo. I can choose either one. It's one or the other. I chose for it to go to the numerator, because if I didn't choose for it to go into the numerator, it would have been in the denominator, in which case I would have had an I in the denominator. Then I'd have to multiply the top and because I is technically a square root, correct? Since I is a square root, that means if I is in the denominator, I have a square root in the denominator, and I'd have to rationalize it and get it to the numerator, and I'd just end up with the answer if I just decided to put it in the numerator instead. So it just makes for extra steps. Lucas?
So if you have to subtract the 7/6, right?
Yes, sir.
Why is it just negative 7/6 if there's already over 6? Does that make sense? Like,
Right, so I subtracted 7/6 to both sides right here, correct? And then I got that answer.
why is there just still a 6 on the Oh,
Because it's the common denominator. It is the common denominator. Okay?
Because you don't actually subtract anything.
Right.
It just makes it
All right, 5 halves minus 1 half is 4 halves. Right. All right? That's as ugly as they get. Well, they actually, technically speaking, could get a smidge uglier. It can get uglier, and those are always air quotes because it's all beautiful math. It could get uglier if my square root number was reducible. So if it was like, if that said square root 72, well, that's 36 times 2, so I could have pulled a 6 out and had a square root 2 and then canceled that with the denominator. It could happen. It could happen. Sure. Could happen. All right, guys. You guys give it a shot. I haven't had wiggly screen anymore. I wish I had a back scratcher in here. I know you would. No. This is one of those ones, it's not quite as ugly as the other one, but it's not pretty.
Are we doing the bottom one or are we doing the top one? Oh yeah, we're doing the top one.
No decimals. No decimals. Right, so that's whatever over 4. Sure. So that's 37 fourths. Mm-hmm. Yeah. Hmm? Right, so but you don't want the 4 over here, so this would be 37 fourths. Don't use decimals, guys. Follow those steps, Sada. That's why I put them. That's why I didn't even have you guys write them. Why I took a full page of writing down every single step. You can just start right there if you like, but I mean. No, don't use mixed numbers. Don't use mixed numbers. Yes. Yes. The sign. Oh, I got all my calculators. No, it's Wednesday. No tutoring today, but I'll still do the video. But for the first bit, right after school, I've got to go watch ASB because Estrada can't leave you guys alone in the room. And I'm not allowed to say anything. What's your question, Seth?
So,
Yes.
I don't know what the square root of this is because there's no.
Is that what you do next?
Complete the square.
Complete the squares next. So let's do this one. This one's a little bit more step by step. So right now you've gotten to this step right here. What is the next step after this?
Complete the square.
So what did I do?
Squared it.
No. If you look right here, that matches completely. I brought in something. What did I bring in?
7/6.
Correct. Why did I bring in 7/6?
That's double it.
It's half of the term right there. So you've got to do half of that term.
So 1.
Don't use decimals.
1 and 1/2.
Don't use mixed numbers either. 3/2. 3/2. Hold on, Emil actually had his hand up, Jada. Is that a T? That's a T. That's a T.
Oh yeah.
That's not a T. What do your B's look like then? Okay. Alright. So yes, T minus 3 halves equals 7. That's 28 fourths, 37 fourths, 37/2. Yeah. All right. All perfect. Let me get Jada, then I'll get it over you guys. No, you did not. Yes.
So when you square this, you take half of it. What's that? Square, right? So this square goes to the bottom.
That's still a T on that. This doesn't change at all.
Oh.
This stays T squared minus 3/2.
Oh, so
No, it's just actually that just stays T squared minus 3 T. Look at here. I didn't change. Right? This is 7/3. It stayed 7/3. And it stayed 7/3. The B term doesn't change. This is correct what you're adding, but there doesn't need to be an over 2. You're not lining them.
Is that right?
Yeah, but you can no, not yet. You didn't get a common denominator right. You skipped some steps mentally, and so you did it wrong up there.
Oh really?
Yeah.
How did I not get a common denominator right?
That's on you to figure out how you didn't do it.
7/1.
And you didn't square it right is what you didn't do.
I didn't square it right. 3 halves times 3 halves.
It's 9/4.
Oh, shit. I'm so sorry.
You were just waiting for that opportunity, weren't you, Lucas?
Is this correct or no?
Let me. Sara's in line. Let me get. Whoa! Hey, I'm getting to you. We've got to follow the steps very carefully. So if it doesn't divide by 2 evenly, let's use this one as the example, okay? So you're starting right here. Okay? Yours just looks a little different. My first step here is to move this number without a t to the other side. So you come over here. Your first step is to move this number that doesn't have a t to the other side. Okay? The next step after that is to figure out what half of that is. It doesn't change, notice, right? It doesn't change. Half of this, which in this case was 7/6, half of this squared adds to both sides. I don't change it though, okay? So after you move that over,
How did they get the 7/3?
so we're starting here. We're starting at that point. We got 7/3 because this one had a number in front of the squared. When you have a number in front of the squared, you divide everything by that a term. So we divided every single one of these by 3. This one has a 1 in front, so we're fine. We can divide everything by 1 if we want, but it's not going to change anything. Okay? So first thing we do is we move that constant over. Then we take half of that, which was 7/6, and square it and add it to both sides. What's half of 3? There is no half of 3 because I don't want a decimal, right? So what we're not going to change the expression, in other words. So this is going to become 3/2. Because 3/2 just means half of 3, right? But since there's not one, we're just going to leave it that way. If we can't actually do the division, we just leave it as whatever fraction it is, unless we can reduce the fraction. But 3/2, can't reduce that. So if we squared 3/2, what's 3 squared? What's 2 squared? Okay, so we're going to add 9/4 to both sides, and that would be the second step. Because we take half of it and square it and add it to both sides. So those are the first 2 steps. If I go further than that, I'm afraid I might lose you. So,
Okay, that makes sense.
okay.
So I put 1.5, but you say you don't want no decimal.
Right. So don't put 1.5 or 1.5. Just put 3/2. Yeah. And then square it.
Which would be.
But put just squared instead. You don't need to actually square it. Right. You can put it step by step. No. I'm saying just put in parentheses and square it or something.
You don't square root the left side.
Not till way later. From that step to that step, we square rooted.
Wait, we have to square root this side too?
Right? But well, that's how we got rid of that squared right there, Tylee. Okay. Yeah. So now this is a perfect square. Now this side's perfect squared, and this side you'll have to solve out. Okay. Yeah.
I already
Yeah.
square rooted that side,
Mhm.
and then do I subtract?
Yeah.
Okay, so then what is
Plus or minus.
after this?
Yeah.
Okay.
Right. And it's this. What's the square root of 37 over what?
4.
No.
Oh, 2.
2. Yep. All right. You guys are at least a few steps in or further. So let's go ahead and you guys, if you just for time purposes, I have to get this one done. So step by step, our A term is already 1. So we don't need to divide everything by 1. That's not going to help us. It's not going to change anything. So I like to say the word gap. I'm going to add 7 to both sides. Right. So I take it, the constant, I move it to the other side. I like to put plus gap, plus gap. Lets me know that I'm going to fill it in. Half of 3. Half of 3 is 1.5. I don't want to square decimals. So if I can't reduce the fraction, I just leave it as the non-reducible fraction. 3/2 squared, 3/2 squared. Because that's what 3 divided by 2 is. It's just 3 divided by 2. This is now a perfect square. T comes down. Minus comes down. 3/2 squared. Which part? Well, this was the stuff I went with you over. Okay, I took half of 3, which is 3 over 2, and squared it and put it on both sides. This is a completed square. When you have a completed square, the variable comes down, the sign in between comes down, that number comes down. You all right, Victoria? Yeah, it's in my middle desk drawer. So this is equal to 7 plus 9/4. I just squared 3 halves. So side work, because I don't need this to be part of my steps. 7 plus 9/4, that's 7 over 1. I'm going to times it by 4 over 4. Yeah. Well, I know how to do this, okay? Question, Sarah. Sada.
Where are you getting all this?
Which one?
7.
The 7 one's been there.
Oh, you wrote.
I'm just doing some scratch work because I want to add these. But I don't want to take a bunch of steps where I'm rewriting the left side over and over again.
Oh, wait.
Yes.
Mark that down, and then you just add the square.
Here I'm just adding to get a common denominator. Okay. No worries. Now I can start. Now I can start getting the t by itself. You're all right. Yeah. All right. I want to get rid of the square, so I'll square root both sides. Okay? Square rooted both sides. There is no square root of 37, but there is a square root of 4, which is 2. Yes. Yes. Add 3 halves. Not only is it going to be a square root of a number, but as far as I can recall, Aiden, that number for the denominator here is always going to end up matching the denominator on this side, so you'll always have a common denominator when you go to do that. And we have our 2 solutions. I am? I will wait upwards of a minute and a half. We are not going to have homework tonight. Good. You should. Today is Wednesday. It is nowhere near, well, I guess it's near Friday. If it was nowhere near Friday, it would have to be, is Saturday the furthest day from Friday? It I didn't mean to ignite like a debate here or anything. I'm wondering, right? I've never thought about it before, Indigo, but I'm wondering if 12:01 a.m. Saturday is the furthest moment from Friday. Yeah, the lowest. Good job using asymptotes. Okay. Equivalently midnight, right? There we go. Okay, guys, bell's gonna ring any second. This will be a part 1 video later on.